Today in our ongoing series of explaining mathematics, we'll be looking at sigma sums. And sigma sums are very handy tools. And essentially it's a machine that we can either use to spit out a bunch of terms, or sometimes we have a whole bunch of terms, numbers, and algebraic expressions, and we're trying to simplify them. So we can kind of go one way or the other, and hopefully I'll explain that pretty well here. The first is that a sum of a series of terms might look something like this: 1 plus 2 plus 3 plus 4. You can imagine what we're doing here. And there's a way to express this using sigma sums. And I'll give you the end result now, and then we'll see how we get there. But this could look like I equals 1 to 4 of I. It could also look like the sum from n equals 1 to 4 of n. So you'll notice that I changed the letter, but essentially it all looks about the same. Now let's go to the next page here and have a little look. So I gave you this term, which is sigma of I equals 1 to 4 of I. Now let's take a look at what this all means. The first thing is on the bottom here, we have our starting counter. And I is going to be the letter we use to, to follow the counting. And the first number that we're going to consider is going to be 1, because I equals 1. And then we'll change that. We'll start with I equals 1, and then we add 1. And the next time we'll look at it, we'll let I equal 2. And the next time I equals 3. And then finally I equals 4. And when we get to a number that is on the top of the sigma, then we stop. And that's simply how we do it. So the first thing is to say, I equals 1, here's I. And we'll take that term, plug in I equals 1 for I. And there's 1. Now we kind of run through the machine one time and come back to the start, so we let I equal 2. And now we have 2 that we add to all this. And then we're going to let the machine go around one time again, and we'll add when I equals 3. And we'll go through the machine one last time, and there we are with 4. And so we can expand this machine. We can take a look at the compact form here and the expanded form here. And each one has its use. Perhaps let's see if we can just do a little example here. What if we had n equals 3 to 5 of n squared? Take a moment, hit pause, and give a think to what you think that's going to look like. So now here we're back. If n is equal to 3, that means we're starting at 3. That's where our counter starts. So I will let n equal 3 first, and I'll insert that as a value right into my little counter there. Sorry, my term maker. And my term maker tells me that I let 3 be the value for n, so that's 3 squared right there. And then we'll go around the machine one time. We come back, next number is going to be 4. And that means that we have to add 4 squared. And then finally we go around the machine one last time, and we come back to our next term, 5. And we realize that's the top term, the upper limit, so we're all done. And we'll let that be 5 squared. Now for your end of the homework assignment, I'd like you to try the following, and we'll see what you come up with, and we'll talk about it when we get into class. So the first is to consider the sigma sum of starting value n equals 1 to 10 of I squared minus 2. And then I'd like you to try to find out what this one looks like. N equals some unknown starting value and some unknown ending value and some unknown term for the following. And we'll see you in class tomorrow.